Hey everyone, Jesse here for 3Prong Gaming, and in the last episode we set it up to where we can click the button and put it here. We set up a bunch of blueprints. It's more involved than just clicking the button, putting that there. So if you haven't watched that video, I suggest you go do so. Otherwise you might be a little bit lost in this one. And at the end of this video, and I apologize in advance, this is probably going to run a few minutes over. I'm going to try to do what I can, but we'll be able to have the mesh follow our mouse. Alright, it's a little more involved, but it's relatively easy. A little bit of math going on, not too big of a deal. So let's go ahead and get this started. Alright, first let's go ahead and jump into the player controller. I do want to tell you guys though that I've been working on the AI for the main project and doing some work on that. And I've made pretty good progress with that, so I'm pretty happy because we're going to be needing that pretty soon as we start doing construction times and all that stuff. But I realized I'm not really following good object-oriented programming, and you should. Even though these are nodes, this is still technically C++, and it's always good to be and have good programming practices. So if you don't know what that is, mostly it's about just keeping things organized, keeping your classes pretty much to themselves. You don't want to pull like variables from a class in another class, and you want to set, you want to make functions called getters and setters. And you want to put those getters and setters, so like if we want this edge speed on a different blueprint, we set it here, or we make a get function to where it'll get it, and then from the other blueprint we call the function, and the function will pull that variable for us. That's the proper way to do it. It makes your project more scalable, more easy to read, and more user friendly. So I'm going to try to do better practices. Now with that, this is the camera pawn controller. We started putting our event construct building here, and it's not a controller function. It's just it's something being passed through from the HUD, and so we should put it where it belongs. Where it belongs is in the ghost building blueprint. So go ahead and Control X. Let's go over into the ghost building BP and Control V here. One thing I did do that I didn't show was class settings. Make sure your iHUD is implemented here in the interfaces. If it's not, you paste before you do. This will say event construct building underscore copy. Now this won't work because that's not the name of the function or of the interface. So make sure you do that first. If not, then just delete that and then re-add event construct building and you'll be just fine. All right, so now let's do some cleanup here. Delete this. And actually, I don't even think we need the controller reference here, but we're going to do it anyways. Grab your controller reference. I don't remember what it looks like, and I don't want to go look at it. So controller reference pulls these out. We don't need this ghost building reference, obviously, because we're in the ghost building. But by doing this, even though these say self, this still won't work because the internal bindings of these calls are referenced from a different class, a different blueprint. So those actually won't work. So let's delete those and we'll re-add them. Kill ghost and on spawn. There it is. So just hook all these back up. And I'm sorry if I go a little too fast in this. I'm going to try not to. But like I said, I to try to maintain my 30 minutes. We got a decent amount of work to do today. So I'm going to try to go through it as precisely as possible, but as quickly as possible. All right, so now those are done. However, this still won't work. The reason why it won't work, compile, save it. Let's go back to the camera pawn controller, is because what do we need to do? We need to go into the HUD, right? We need to be able to pass the reference, because right now in the HUD, if you look at the graph, it's sending the interface call, the message is sending it to the controller reference. Well, we just moved it from there. So we need a reference to the ghost building ref, hit enter, and we will make it of type ghost building BP reference and expose it on spawn and editable. And let's go ahead and set its category here to references. Drag this out now. get it, and plug it into the targets. Now it'll send this message to the ghost building reference. Compile, save it, and again, it still won't work. So let's go back into the pawn controller. The reason why it won't work is because we're passing in the reference of ghost building BP right here. However, at this point in the graph, it's still null. See, we don't set it till down here. It's pin 3. This is set on pin 1. So what we need to do is we need to just take this, drag it all the way down, disconnect this link there, and then just slide these pins up like so. Come on, there it is. And grab this. Let's just slide this up a little bit to right there. And then grab these, move this up. Now, plugging that in there. Now we have a valid variable filled with the instance, and it'll populate that. So let's just confirm that that should work. Cross my fingers that I did hook that all up right. And there it is. Okay, good. So that all works. Now let's jump back into here. So what we need to do now is we need to create, actually, let's jump back into the pawn controller here. We need to create a tick event here. Tick. All right. And with this tick, we need to create a new variable called build mode active. Leave it as a Boolean. Okay. Branch. There it is. Branch it. Now this portion of the tick, we'll probably end up having to run a sequence in here, but we don't need it right now, so I'm not going to worry about it. Take your build mode active. We only want to run this if build mode is active. And what we are going to run is we need to create some functions here. We're going to create a function library, and we're going to get all the way through that. But we need our ghost building reference. Get that. Now, this probably isn't fully necessary, but I like to just be safe. Now, ghost building reference should never be null, but just in case it is, we need to run for that, because the process of getting our mouse position on a tick basis, it can be expensive, and so let's not take any chances, okay? So we got that. Make sure that it's not null. All right, now we need to go in here, go into your top level, and add a new folder. Let's call this one libraries. Okay, open that up. Right click, choose blueprint function library. We're going to create a function library that we can use anywhere, anytime. All right. Open the sucker up. Our first function, let's go ahead and call this set cursor world position. Hit enter. Now we're going to need a couple inputs for this. So select new. This first one we will call controller. Make it of type camera pawn controller reference. And then the second one, let's call this one sight distance. Make it of type float. Okay, and the sight distance, I'll explain a little bit further, but this is pretty much how far you're going to be able to place the mesh out in front of you. We need to take account of it in the set cursor here in the function. So yeah, it'll all come together. You'll see. All right. Then the output, we need to set this as a vector, right? I'm not mistaken. Yep, vector. We will call this, come on. We will call this location. We could probably call it mouse location. We'll just call it location. That's good enough. Okay. So from there, we need to pull off this controller and go convert mouse location to world space. All right. So that's going to know exactly where our mouse is at all times. Now we take this sight distance, actually take the world directions. Just easier because then you don't have to switch them around. Hit multiply because this needs to be in the, oops, not vector by vector. Multiply vector times float. Okay. And the reason why I drag off of here is because then you don't have to switch the pins around. So now take our sight distance here and plug it into the multiply. Pull off your world location, add vector plus vector, then take our multiplied value right there, plug it in. Now we're going to run a line trace, and that's what this is. That's going to be our end point of our line trace. Okay, so let's do line trace by channel. Okay, and we're going to create a custom channel here in just a second. Hook this up like so. All right, like I said, this is going to be our end. So go ahead and plug that into the end there. Take our world location and plug it into the start. Okay, so we're taking our sight distance, multiplying it by our world direction, which will tell us whichever way the camera is facing. And then it'll add it to the world location and set that to the end point. And our world location is where we want to start the trace. So now we need a custom trace channel. So let's go over here and select project settings. Let's go into collision. Now you get, between your object channels and your trace channels, you get a total of 18 combined custom in between them. So if you end up having a lot, just try to use them sparingly. 18 seems like a lot until your project gets big. All right, new trace channel, click on that. Let's go ahead and call this one landscape. And its default response, let's go ahead and set it to ignore. What this will do is every blueprint, everything that's already created in the project, we'll add this new channel to it, and it will set its default value to ignore, which is what we want. The only thing we really want to add this to is anything that needs that trace channel, which in this case right at this point will be the landscape. That's why we named it landscape. Okay, go ahead and close that. We'll need project settings again at some point here soon, but for now that is good enough. So now real quick, go to your landscape. You will see under collisions, this was defaulted. This is like the 5th time I've recorded this episode. It was defaulted under block all. What we want is custom, and then landscape. See, it set it by default to ignore. We want it to block it in the collision or in the trace response. All right. So Control S. I don't understand what that's all about. Yeah, I don't understand what that's all about, why it does that, but it does. I've been seeing some comments about it on Answer Hub, but we'll deal with it. Let's see. Okay, back to our function library. So now change this trace channel to, oops, we need to compile it so it sees it. What the heck? Let's close it out, open it back up, see if it sees it now. There it is, landscape. Select that. Okay, now we need to break this hit. Break the hit results. Now this part is uber important, okay? And if I remember, I'll try to demonstrate why it's important, but we need to take the hit actor and we need to do a check, not equal to, okay? We need to make sure it's not null. If it's null, what it's going to do, because trust me, moving the mouse around every now and then, it's going to pick up a null pointer, and it's going to, your mesh will zip to the 000 axis of the screen when it's null. So I had an issue with this, and finally somebody gave me some help on Answer Hub and said, hey, you're pulling up a null pointer. You need to account for that. So that's what I did. And if, like I said, if I remember, I'll demonstrate to what it does. Now we're going to get an issue here when we compile it. We're going to get a note. Now this note says info, the execution path doesn't end with the return node in the false. Okay, and that's fine. We know it. That's not a big deal. We can still run. It's nothing. It's just telling you, hey, be careful, especially since this is in a function. Usually functions, it does that. Macros, it won't do that. But we can't run off of this, and this is how I'll test it later. If we ran it into here, well, it'd be just like not having this. If we ran it into its own return node, like right here, and didn't plug anything in, well, it'd still be like having a null pointer, be 000, and that's what happens when you have a null pointer, is your mesh will zip to 000. Okay, so that is it for that. Let me show you guys what's going on with this real quick, so you can just kind of take a pause break for it. Okay, hard to see. Convert mouse location to world space, multiply it by sight distance, add location and direction together right there. Plug that into the end of the line trace by channel. The start is the world location. Trace channel is landscape. Break the hit hit actor not equal to null. If it's true, then take the location and return that. Okay, and that's our function library. We're going to have to come back and set up another one in there in just a minute. But let's go back to the camera pawn. So now we need to add that. So set, not set, what is that? What did we name? Yeah, set cursor world position. So let's go ahead and drop that in there now. And we need to plug that into the true. And then the controller, obviously we need a reference to self. And then from there, sight distance. Let's go ahead and create another function. And this one will just be a local function. So go ahead and create new function. The thing with the sight distance, if we don't do this, the trace runs from the camera. Okay, so let's go ahead and call this set sight distance. And no input on this. Actually, we're going to make this a pure function. And this function library, while I'm thinking about it, this needs to be a pure function as well. Okay, compile it, save it, come back in here to the camera. All right, so all we do need an output on this. Select this. We will call this the sight distance, type float. Now, what I was saying was the trace runs from your camera. So whatever your sight distance is, if you're, if you only want to be able to place blocks 1,000 units in front of where you're at, if you're zoomed all the way out, say you're zoomed 2,000 units out, your mesh will never touch the ground. So we need to get rid of that spring arm. We need to account for that. So it's just going to make it a lot easier if we do that. So camera pawn reference, drag off of that. We need spring arm, get spring arm. And then from the spring arm, we need the length, get target arm length. There it is. Oops. So now all we need to make a new variable now. Call this not a local variable, a regular variable. Let's call this sight distance. Type float. Compile it so we can set it. So now this will automatically account for the spring arm. So we just know right off the bat that, okay, we only want to build 1,000 units out, okay? Compile it so it sets that. Take your sight distance, drop it in here. All we need to do is add your sight distance, float plus float, to the target arm length. Plug that in there, compile it, save it. All right, so now let's go back to the event graph. We need to lower this. Take our sight distance set sight distance variable we just set, plug it into the sight distance, and perfect. So now whenever we need to change our sight distance, if we want to go further, then just change this variable and you will be good to go. Let's not make this. Yeah, no, that's fine. Let's go ahead and grab. I'm trying to think. I didn't set that pure in my. I thought I said that pure in my other project, but I didn't. Anyways, it's fine. It will work. Grab your ghost reference, drag it in there. We need to set. Oh, we didn't make that variable yet. Go into your ghost building BP. We need to make a new variable. Let's call this cursor world position. Hit enter. Needs to be a vector. Make it editable so we can edit it in the other blueprint. Compile, save it. Go back to your camera pawn. Now we can pull off of here and go cursor world position. Oh, no, delete that. We need to set cursor world position. Set it. Okay, and just plug it into the true of the branch. Take our location from that and plug it in there. Good deal. That will work just fine. Okay, now I want to take all this though, and let's go ahead and plug the true into that. Select all that except for that first branch. Right click. I'm just going to collapse nodes. It just cleans it up a little bit, and we will call this set cursor world position. Okay, so there we go. We jump in here, And we could probably take this just in case we place anything afterwards, just so it hooks up the execution pin for us. Okay, and that's it. So take a look at that. Okay, and just again, I'll give you this, a look at this real quick. That's a really simple function for set site distance. Okay, and then back in here, create HUDs. Do we set that? Yeah, we didn't. Let's close that then. Okay, so now we need to step back out of that, and that should be good for now for our tick event. All right, so now this will only work when build mode is active, and we will set build mode in our ghost building BP. We're at 20 minutes. Hopefully we should be able to get this done. Like I said, I might be a few minutes over, hopefully not. All right, now we need to create a tick event. So go ahead and call tick. Zoom in here, we need a couple custom events. We will call this one open tick gate. And then we need another one, custom event, close tick gate. This saves you from having to run wires everywhere across the whole blueprint. Looks relatively ugly if you do. So we need a gate. We want our tick event to enter the gate, but we only want it to come out when this event is called, and we don't want it to come out when we close it. Okay, so that works for that. We need now, let's see, we need a reference to self. Let's just go ahead and finish setting this up. Oops, self. And now we need to set actor location. Where is it? There it is. Plug that into there. And the location we're going to get, we're going to have to set again. So we need to create another function. Let's go to our function library, and we will create function, call this one grid snap. Now this function will allow us to snap it creates like an invisible grid for us to use. Okay, we need a couple inputs. Oops, do that, couple inputs. First one we will call axis. Hit enter. We need it of a float. It's going to take the axis of our cursor world position and adjust numbers accordingly. So now we need grid size. This will be an integer. Okay, and on the output we need to output another float. This will be the axis out, and we'll just call it axis out, and this will be a float. All right, go ahead and create some space for us here. All right, now what we need to do is we need to take this grid size, pull this out. What this will do, we need to divide integer by integer, divide it by 2, so that way it'll get the center, because the cursor is going to be in the center of our mesh when we're moving it around, so we need to find the center point of that. Okay, take our axis value, and this will be all 3 positions. You'll see in just a minute. We need to add float plus float. Okay, move it out to here. Take this and just plug it in. It will automatically convert it to a float for us. All right. Now, after adding our axis value to the grid size, we need to take this now, and we need to divide it. Oops, dang it, I hate that. Divide it, float by float. All right. Yep, now we need to take our grid size again. We need to divide it by the grid size. It'll convert it for us again. Let's just move that down and out of the way. Okay, now with this, we need to take the floor. Floor will round it down to the nearest whole number for us. Okay, and then take this floor now, and we need to multiply that. Man, I hate that. Please fix that, devs. We need to multiply that integer by integer. Now take our grid size and multiply it. This one's kind of hard for me to explain. I hope you guys kind of see what's going on. Ultimately, we're just finding the center point of what we determine as our grid size, add it to where the axis is at, which the axis is going to be the cursor world position in 3D space, and then it divides it by itself to get the smallest number, and then we multiply it. So we're just kind of rounding out the numbers here for this. Sorry, I'm not going to spend much time converting this, or try to make this pretty. I'm sorry. All right. I'll come back and do it on my own time. Now just convert that to a float for us, and we are good to go. So go ahead and check that out. relatively simple, hard to explain, but relatively simple. All right, compile it, save it. That is our grid snaps. Now let's go back into here, and we need to create a new function, local function. We will call this one set grid snap vector. All right, no inputs, but we need an output. We will call this grid snap, or right? Yeah, I think that's what we'll call it. Is grid snap, and then we need to make it of type vector. And create a little bit of space here. All right, take our variable cursor world position, get it, split the struct, right click and split the struct. All right, now we need to get our grid snap function that we just created in the function library, select it, and we didn't make it pure. We need to go back and make this a pure function. Select that there, compile, save it. Now jump back into here. There it is. We need 3 of these, 2, 3, line them all up right here. And then just plug the X, Y, Z. Now we need to pull off this and make vector, and then just plug them in like this. Okay, now we need a new variable, not local, regular variable, call grid size. Needs to be a integer. Compile it so we can set default. I'm going to set mine to 50. You can set whatever you want. This grid size though, keep in mind, whatever you set this to, it is best when you create your meshes and put them in the world that it is divisible by that number. Okay, it's just going to make for better user experience. It's going to be a better layout. So just try to keep that in mind. You can set this to whatever you want though. I might show you if we've got time. I'll demonstrate a little bit. Plug it into all 3 right there. Take the return value, plug it into the end, take a look at it. All right. Now let's jump back into the event graph, and we need to take this set grid snap vector, drop it in here again. I forget to do that. We need to make it a pure function because we don't need it hooked up. It's just returning values for us, so we have no execution going on. Jump back into the event graph, and not set clock, set grid snap, drop it in there, and then just plug that into the new location. Okay, compile, save it. That is it for our tick event. So what we need to do now is we need to open the tick gate and close the tick gate. First, we need to open the tick gate at the end of our on spawn. Open tick gate. That'll work. And then this one we need to set in our kill ghost, but I don't know why I did this. You could probably set it at the end, but close tick gate. You could probably set this at the end, but I set this right here in my other one, so I don't remember if I had some problems getting it to close or display properly, so I put it right there, so that's just where I'm keeping it. Okay. Other things we need to do is remember in here, we'll never get cursor world position unless build mode is active. So go back to your ghost building BP, and up here in on spawn, let's do this under or right after the set active. Actually, let's go controller reference, drop that in here, and build mode, set build mode active. Okay, plug that in there, plug that one in there. I'll make things pretty a little bit later. Dang it. Plug in there. Okay, and then we need to come at the end here, and we need to do the same thing. So we could just control W, set those right there. And this first one though, in the on spawn, we need to set this one to true. We spawn it, we want it true. We kill it, we want to disable that. Compile, save it, and I believe that is it. And that's not it though. We need to go right here. Remember, we spawn the building into the world simply so we can get these variables from it, the display mesh and the proxy mesh. And there's probably a better way to do this. Really, we could probably go in and set this, all the building master BP to default to being hidden. But but it's not that big of a deal, at least not right now. We need a sequence. So hold S and click, hook up the sequence. All right, pin number 0 will go into that. What we need to do after we set all those variables, we need to come down and we need to destroy actor. There it is. Okay, so after it's done setting all the variables for us, we destroy it so it's no longer visible in the world. Okay, and like I said, we could probably set the building master BP to be hidden by default, and then when we actually spawn the building and place it in the world, we just set its visibility to true, but not a big deal. We still want to destroy it. All right, and I think that should be it. Cross your fingers. Let's check it. Sweet. There we go. Now we do have a problem here. It probably won't show it right there. Let's back out of this really quick. We are just over 31 minutes. So let's try to make this quick. Go to the main UI. Actually, we need to go back here. Go into our buildings, commercial, right click at commercial master, create child blueprint. Let's call this one construction office underscore BP. Open this up. The only thing we're going to do in here is change its default mesh. Pick whatever mesh you would like. I think I'm going to go with the shape tube. Compile, save it. We can close that one. Go into your main UI and now change this building class to your construction office. And that's all you have to do to add buttons. You add your buttons and then add the message call to it, and then bam, just set this. Whatever building it should be, construction office, apartment small, is what it will pass through. So now let's go ahead and push play. So now we go like this. Click your construction office. Now, oh, it's not going to do it. Need to, when you go underneath here, I already did it, like I said, I've recorded this a few times, is the collisions. You need to go into your ghost building, right? Select the mesh, go under your collisions, and you need to change this. It's defaulted to block all. You need to, let me show you what it does. It defaults to block all, push play. Look at that. All right. It's because it's blocking it. So we don't need any block with it anyways. We just need to overlap with it. We're going to run some checks on it to make sure it's not overlapping anything. So just set it overlap all. And then as you can see, it does just fine. Now let me show you real quick. I know, I'm sorry, I'm over 30 minutes. I told you I'd keep it under, but there is still one more thing important I want to do. But let me show you what I was talking about with this cursor world position. If we ran this, if we didn't have this null pointer check, like I said, it'd be just essentially the same as doing this. If we didn't have this null pointer check, compile, save it, play it. Now watch, see how it's zipping. I'm pointing at the screen. See how it's moving around. It's picking up null pointers when you're moving your mouse around. And so that's not good. So you have to have that in here, which will fix that problem for you. All right. One last thing I want to do. Let's go into project settings. All right. We need to create a new input. Go into your bindings, action mappings. Let's add a new action mapping. We will call this one deselect. Hit enter. And this will be right mouse button. Yeah, the right mouse button. And then close that out. So now let's go back into the camera pawn controller. Right click, do some deselect. Okay, input action deselect. We need to pull off of here. We need to do a branch. There it is. Pressed branch. We only want, if we want to utilize the right mouse button for other stuff, then we'll run a sequence. That's why we're doing this branch as well. Is if build mode is active, then what we want to do is just get our ghost building reference, get it, and then kill ghost to true. Oh, come on. I don't want to clean this up right now. And then we will set our build mode active to false. Okay. So if we right click in the screen, so compile, save it. That's all we got to do. Push play. We got this out here. Right click and it didn't do anything. Ha ha ha, tricked you. What we need to do is when we kill the ghost, even though we set the display mesh to none, we essentially froze it. So what we need to do is we need to get the display mesh, right? No, we don't need to get that yet. We need to, no, here's what we need to do. We need to get this display mesh, drag off of this, set static mesh, and even though we clear it out right here, we'll take this and plug. You can leave it as empty, but we're going to plug it in just to be consistent and know what we're doing for sure. And we'll just set it to the new display mesh, which at this point will be nothing. All right. So now, come on, only because I'm trying to get this done and over with. Compile, save it, push play. Now, right click and it disappears. Construction office, right click and it disappears. Right? And we click on construction office, it changes it for us, it kills it all for us. Awesome. Perfect. Now the site distance, let me show you here. Now, is the only 1,000 users. See how far that is right there? That's it. That's as far as you can go. All right? Even if we scroll out, that's the function we set. It takes the distance of the spring arm into account. 1,000 units is only going to be 1,000 units from where this is at, actually, from where the sphere is at. All right? And that's it. That's our 1,000 units. Now, just real quick to demonstrate, if we went to, where is that here? We go into site distance, and let's just set that to 5,000. Compile, play it. Now you can go way out there. See? All right. That's what your site distance does. That's where we take that into account. And that is it. We're at 37 minutes, or just over 37 minutes. I apologize it took this long, but hopefully you guys learned a lot from this. It took me several times to record this, and I wanted to do it as perfect as possible for you guys. So I hope you enjoyed it. If you did, please do me a favor, go down, hit that like button. It helps me out a ton. If you're new to the channel, go ahead and hit the subscribe button while you're down there liking it. And until next time, peace.